So we're here with Wasim Khan from Naughty Dog. You're the lead technical director. You just wrapped up some amazing work on Last of Us Part 2. You've gotten to work on Uncharted 4. You've worked on Uncharted. Some of the highest rated games ever on the PlayStation. Thank you for coming on. I saw some of your viral tweets that you put out about your Last of Us work around the rigging work around Ellie. It was amazing stuff. So we had to have you here. As a technical director at Naughty Dog, what is it that you do?
First of all, like I get to bridge the gap between art and technology, and my primary job is to design, create, maintain character rigs and deformation system, and also provide workflow tools for animators and character artists to ease their workflow. So I'm gonna start with Ellie's face rig. So some technical specification, while I was creating this Alice face rig, we had some consideration coming from Uncharted 4 and Lost Legacy, and we had some workflow improvement that we wanted to do. One of the constant requests that I received from the animator that how we can improve our face rigs. And there are a couple of workflow that our animator was used to, and we started onboarding some new animators. So there is a constant debate about how should we approach animation controls. So there is one huge switchboard control that you have all list of attributes that you want to animate, and some animator likes animating on face controls. So I wanted to find a best medium that will facilitate this workflow in more meaningful way. And using Maya's proxy attribute, I managed to create this rig that facilitate this workflow without disrupting any other animator. So they can animate with this whole list of attribute, which fax rig can get really extensive. In our animation rig, we had more than 100 channels to animate with, and it could get really extensive if you add more trigger controls.
So how are you getting this fax, which obviously looks like a blend shape kind of base rig? How are you getting that in engine?
So in engine, we don't support blend shape. So what we do is over the period of time, we kind of realize is I'm going to say smooth skin decomposition, and I will try to explain as we move along. But that kind of became our main workflow for exporting our data into a game engine. So what we do is we try to compound our layer of deformation into one single stack of skin cluster. So if you have blend shape skin, any wall space deformer, what we try to do is feed that data into SSD, and SSD will try to figure out the final compounded skin cluster that we can send into a game engine. So yeah, cool. In this case, like we had about more than 2,000 shapes, and we had 350 joints to calculate the final skinning for Ellie's face. And one of the approach that we took is generating this face rig is, I call it more of a data-driven face rig. Is we used to get, because we have this very talented team in San Diego that does scanning of the character, scanning all the fact shapes, and then doing retopo, remesh, and creating the final actor base final shapes for our game characters. And that data can get really extensive. So the approach we took here is I used to get this huge list of attributes data from our other partner studios, and in this defines how the animation control is going to get built and how the combo shapes is going to get driven from the particular channels, and this led to a very smooth workflow to create this extensive cast of character and keep creating, because this process is a very iterative process. We go back and forth from the animator to shapes team, again back to TDs, generating that final data, sending to a game engine. And because everything we evaluate that supposed to be a final game data, so that turnaround is supposed to be really quick, and this led to that workflow in a very fast manner. So for the blend shape, as my first slide I showed is like a 20K head, and what happens? We have this 20K head, and then we have this 350 transform that's going to drive the final scanning. What I do there is I literally find out which is the meaningful faces. I try to find the closest face that I'm going to use for riveting or join to the face, and that means I'm going to care about technically only 350 faces. So what I do is I try to get rid of everything else that I'm not going to find it useful. That led to a couple of workflow improvement. One is the blend shape file itself was about 125 megs, and get rid of unused faces that reduced down to 23 MB. So that means more animators loading that data from server faster. They're not paying a cost or waiting for to load 100 meg every time they reference Ellie character into the game engine. And with that 350 transform, I managed to calculate the final SSD skin for the final mesh. So
Awesome.
this is the quick example, because that Rivet mesh is still live in Maya, and that transform that's going to get calculated in the end. So getting this final kissing scene was super complicated to get that into a game engine, but I can apply any world space reformer like soft mod control or cluster, and then give it that handle to an animator to animate with. So same thing, you can see that some uh, arrays of reaction with the ground.
Can you run any physics or anything on the joints once they're in engine?
Yeah, absolutely, and I think that could lead into our second conversation.
Okay.
So. Uh, uh, Smooth skin decomposition kind of became a main workflow for our final deformation for the character. So like we knew when we were working on over the period of time on Uncharted 4 and Lost Legacy that it really works well on character faces. But in that case, all the transforms are baked. In order to get that tech working on our character rig, we wanted to make sure that rigs run runtime in game engine, because we have full body IK and we cannot export those 700 joints and bake that transform and send it to a game engine, because it's going to be a really tough to manage in terms of animation memory. And we also introduced motion matching. So we wanted to have a number of possibility when we transitioning into a different state for the animation, and making that a runtime really helped to produce a very cool effects. So there's a couple of way we thought we're going to approach this one. One of the very useful ways, either corrective shape or PSD. Either you can add some sort of a blend shape or some sort of a deformer front of the chain, or post deformation of the skinning. So that way you can add some corrective blend shape to get the deformation looking right. But the problem with that is you have to bake or create some sort of a deformer that works on a vertex level. The problem with that is we don't support blend shape into a game engine, so we wanted to find a more optimal way. And in case of Ellie, we had 20 outfits for Ellie for all different phases of the game, and then creating corrective shapes for 20 outfits, you can imagine the nightmare situation. So we wanted to find like how we can make this more artist friendly and more author, because in Naughty Dog we believe in iteration. We constantly iterating on our character. So I knew from the beginning that I need to create a tool set that will help facilitate that workflow, able to improve and keep retouching our asset. And like we don't have any distinction between a cinematic asset or gameplay asset. Everything we author on highest possible log, and every mesh we have like 4 logs. So we try to generate everything, all the skinning, all the low resolution meshes on the build time for free. So like we knew SSD had the answer. It worked really well for our faces, and we wanted to incorporate that into our body rigging. So this is
Can we
where
jump
this.
ahead and see? We really don't have a lot of time left. This
Yeah,
10 minutes is really tight time, but
yeah,
this dog rig is really
yeah.
cool. So you're using the same skinning decomposition tricks here that you're using in the
Right,
face to
right.
drive the muscle and skin here, correct?
Yeah, exactly. So, in this case, like I have about a 56 and 138 deformation joint that gives you the final deformation for the dog, and it goes through multiple phases. So, just want to give like quick rundown that how it goes through the pipeline. Just need a base mesh and a skeleton, and once we have the defined range of motion, artists can go and sculpt it, or you can generate the shape through some sort of a physics-based muscle rig. And these were the tool that I provided to the artist to facilitate that workflow. It goes through multiple steps. First step is finding out the error map. Error map is SSD telling you that it's trying to reach that goal and couldn't reach for those set of vertices, and I use that to generate the post joint, and those post joint then later on can be turned into a procedural rig. And then we go to the next stage, and those procedure joint can be turned into a physics joint if you wanted to. So it's a very artist friendly and a very author driven workflow.
Man, that is a lot of stuff. That's amazing that you got all that squeezed into 10 minutes of time. Thank you so much for coming on. We have a Q&A at the end of this, so Wasim and myself will be available for that Q&A. And we're both on Twitter, so feel free to come have a conversation with us there, because you'll check out those viral tweets. But thank you, Wasim, for coming on. We really appreciate you doing this, man.
Thank you so much, Will.